Hello, good morning all. My today's topic is G.O.C. In G.O.C, I will tell you how reactant reacts and give product. Basically, reactant react and gives product, but they do not give product directly. In between, they produced a short-lived species which we call um in between they produce short-lived species which we call intermediates intermediates or transition state transition state. Both are short-lived species, but the lifespan of transition state is very short, very short than intermediates. Intermediates have also short lifespan, but the lifespan of transition state is very much short than the intermediates. The examples of the transition states are activated complex, which we study in the chapter of chemical kinetics. And the examples of the carbocations are the examples of the intermediates are carbocation, free radical, and carbanion. Carbocation, carbanions, and free radicals are examples of intermediates. So in this, what I have tell you how reactants reacts to give product. Basically, the reactant directly do not give the product. In between, they form short-lived species. These short-lived species are intermediates, or they may be transition state. What is the difference between the transition state and the intermediates? The transition states have very much short lifespan than the intermediates, and the examples of the transition states are activated complex, which we study in the chapter of the chemical kinetics, and the examples of the intermediates are carbocation, carbanion, and free radical. Now, these intermediates do not form directly. What we have to put in the reactants? We have to put attacking reagents. Attacking reagents in it. Attacking reagents are of two types. They may be nucleophile or electrophile. Okay? So reactant do not give product directly. In between, transition state or intermediates are formed. These intermediates formed by the attacking reagents, and these attacking reagents may be nucleophile or electrophile, which will form the carbocation, carbanion, and free radical. It depends upon which attacking reagent you have put in the reaction. Okay, so now I will tell you in another step, in another slide, I will tell you how the intermediates are formed. Okay, so in another slide I have tell you how these intermediates are formed, and then after that I will tell you what are nucleophiles, electrophiles, and okay. So now the another topic is cleavage, or we call it fission. Cleavage, or what we call it fission. So fission is of two type. Fissions. What is fission? Fission is basically CC bond. How this CC bond breaks. Basically, we call it fission. The breaking of CC bond is known as fission. The fission may be of two type. It may be homolyptic, or it may be heterolyptic fission, heterolyptic fission, and homolyptic fission. Okay, fission. In homolyptic fission, the CC bond breaks symmetrically. This bond breaks symmetrically, which means this bond is made up of one atom, one carbon atom, and another carbon atom, and this bond, when this bond breaks, this carbon atom attains or takes the electron, and this carbon atom takes the electron, and they will form free radical. What we call them? Free radical. Okay. Heteroleptic fission is unsymmetrical fission in which one carbon gains electron and another carbon loses electron. The carbon which gains electron, it will call carbanion. Carbanions means the carbon which carry negative charge, and the carbon which carry positive charge or which loses the electron, it will carry positive charge, it will call carbocation. The carbocations means the carbon which carry positive charge or cationic part means positive charge, it will call carbocation. So basically in this topic I will tell you the fission. What is fission? The fission is of two type. Fission means the breaking of the CC bond is called fission or cleavage, and the cleavage or fission is of two type, homoleptic and heteroleptic. In homoleptic fission there is a symmetrical cleavage of the bond in which they form free radicals. In heteroleptic fission there is two types of the intermediates formed, carbocation and carbanion. Carbocation, the carbon which carry positive charge or which loses their electron is called carbocation, and the carbanions are those intermediates which gain electrons and they will call carbanion. Okay, hope you have cleared this topic. Now our another topic is attacking reagent. So my another topic is attacking reagent. So I have tell you the reactant directly do not gives product. They will form intermediates. These intermediates, after that they will produces the product. Now these intermediates do not form directly. What we have put in it? Attacking reagents. These attacking reagents are of two type. It may be a nucleophile, it may be a electrophile. Now in the another slide I will tell you what are the attacking reagents, and they are of two type, nucleophile and electrophiles. So in another slide I will tell you what is nucleophile and what is electrophile. So let's see what is nucleophile and electrophile. So I will tell you nucleophile and electrophile. So nucleophile is the species which is nucleus loving, and electrophiles are those species which is electron loving, which means nucleophile loves proton, positive charge, and electrophiles are those species which loves negative charge. Now let me tell you some examples of the nucleophile. The examples of the nucleophiles: all the anions. Anions are the species which carry negative charge. Okay, so all the anions are examples of nucleophile. For example, chlorine, H negative, Br negative. All these are examples of nucleophile. Now species which carry lone pair, which having lone pair in it, is also act as a nucleophile. The examples of the lone pairs are like NH3 having the one lone pair, water having two lone pairs, so it will act as a nucleophile. So what I have tell you, the nucleophiles are those species which love nucleus, which loves positive charge. The examples of the nucleophiles, all the anions are nucleophiles, and the species having the lone pair in it act as a nucleophile. Now I will tell you what is electrophile. Electrophiles are the species which loves electron, which loves negative charge, but they carry what charge? They carry positive charge. So all the cations are electrophile. All the cations, example H positive, NO positive, all these are electrophile and act as a electrophile which carry positive charge. They attract towards the negative charge. Okay, and multiple bonds. The species carry multiple bond, also known as electrophiles. For example, CO2. CO2 is an electrophile because CO2 have two double bonds in it. SO3 also act as a electrophile because it will also carry the multiple bonds. So the electrophile is the basic difference between the electrophile and the nucleophile is that the electrophiles are the species which loves electron, and nucleophiles are those species which loves positive charge or nucleus lovings. Okay, all the nucleophiles are the species which having the lone pair in it and having anionic charge on it. Okay, the electrophiles are those species which have cationic charge, means which having the positive charge and multiple bonds. So this is the this is how I differentiate between the electrophile and nucleophile. Hope you clear about the nucleophile, electrophiles and intermediate, what are the intermediates and how the reaction proceeds, how the reactants convert into the product. So I hope you like this video. Okay, thank you guys.